Intel's new chips are scaling agentic AI from the data center right down to your laptop. Anthropic just designed disease fighting molecules with a near perfect success rate, and a potential $13 billion acquisition might just redefine open source AI. What does all this mean for us builders? No BS AI briefing brought to you by Proactive AI. Welcome back. I'm your host Vikash Sharma, and this is where builders get straightforward AI news without the fluff. All right, let's dive in. We've got some really high signal items that are going to impact how we think about building. First up, Intel made some pretty significant announcements at Hot Chips 2026, unveiling their plans for agentic AI architectures. They detailed their next gen Xeon, which they're calling Diamond Rapids, alongside a new data center GPU, Crescent Island, and the next iteration of Intel Core, Wildcat Lake. In plain English, these aren't just incremental bumps in performance. Intel's designing these chips specifically to scale agentic AI workflows from the massive data centers all the way down to the edge. They're talking about advanced packaging and even the first use of UCIe in an Intel processor, which is a big deal for modular hardware. For builders, the interesting part is the signal that running sophisticated agents locally is becoming a practical reality. This could drastically cut down on latency and cloud costs for certain applications, making us really re-evaluate our edge versus cloud trade-offs. The move to UCIe also signals that modular composable AI hardware is hitting the mainstream, which means more flexibility and potentially more competitive pricing in the future for specialized compute. Next, Google Cloud is deepening its ties with enterprise, announcing a strategic partnership with Verizon to scale enterprise AI. This isn't just a regular customer deal. Google's integrating its Gemini Enterprise models and its entire data and AI stack directly into Verizon's operations. The focus is squarely on modernizing customer experiences, unifying their massive data sets, and perhaps most interestingly, enabling autonomous network intelligence. So, think about networks that can largely manage and optimize themselves. For us builders, this isn't just a big enterprise deal, it establishes autonomous network intelligence as a genuinely viable and significant product category. It also sets a pretty high competitive bar for what large scale autonomous systems can achieve when built on top of a platform like Gemini. Are you building on a major AI platform, or are you trying to differentiate from them? That's a strategic question this partnership really brings to the forefront. Also, we saw some incredibly promising news from Anthropic. Their AI reportedly designed disease fighting molecules with an astonishing 14 successes out of 15 attempts. Now, this wasn't some theoretical exercise, it's a real world validation of AI's capability for drug discovery, moving well beyond just text generation or image recognition. This means their models are demonstrating a deep understanding of complex molecular structures and interactions. For builders, this opens up a viable, even exciting path for AI native biotech and materials science products. Imagine startups that can leverage AI to rapidly prototype new drugs or materials with unprecedented accuracy. The 14-15 success rate isn't just a number, it's a benchmark. It challenges us to define our own domain specific success metrics for AI driven design and validate our concepts with similar rigor. Then there's been chatter about Hugging Face. TechCrunch reported that they're in acquisition talks, potentially for over $13 billion. Now, the deal isn't finalized, and Hugging Face's CEO has made comments that seem to emphasize their long term community responsibility, maybe casting some doubt on an immediate sale. But regardless, the mere report underscores the massive strategic value of open source AI infrastructure. Hugging Face has become the hub for so much of the open source AI community. For builders, any shift here could have significant implications. We'd need to monitor closely for potential changes in licensing, pricing, or even the governance of the platform. Will it remain as open and community driven under new ownership? That's a big question, and the uncertainty itself forces us to consider our dependencies on open source ecosystems. Finally, OpenAI made some interesting moves on two fronts. They paused development on certain frontier models for safety reasons, specifically mentioning that Astra remains on hold while they shore up guardrails. Simultaneously, they launched ChatGPT for ages 13 to 17, complete with new safety features, and reiterated that enterprise client data won't be saved or used for training. What's the big picture here? Well, for builders, safety isn't just an afterthought anymore. It's becoming a competitive constraint, and we should expect tighter standards across the board. The clarification on enterprise data handling is also material for anyone using their APIs. It impacts trust and compliance. And the teen launch that significantly expands the total addressable market for conversational AI and could spark new competition for youth focused products. Are you thinking about how your product might appeal to this newly validated demographic? All right. If I had to pick one story that really stands out this week for its potential long term impact, it's Anthropic's molecular design breakthrough. What happened is pretty incredible. The report indicates that Anthropic's AI managed to design disease fighting molecules, hitting a success rate of 14 out of 15 attempts. This isn't theoretical. It suggests the AI can handle multi step scientific reasoning and with real world implications. It's a tangible demonstration of AI moving from general purpose reasoning to highly specialized, impactful domain work. Why does this matter right now? Because it validates AI's capability in an area that has historically been incredibly costly, time consuming, and resource intensive drug discovery. This kind of success rate means the AI isn't just suggesting possibilities, it's actively helping create viable candidates. It's a huge signal for the convergence of AI with deep science, potentially shortening discovery timelines and reducing the massive failure rates traditionally associated with early stage drug development. This could spark a significant acceleration in AI adoption within biotech and pharmaceutical industries and fundamentally change how new molecules and, by extension, new materials are brought into existence. Who should care about this? Well, obviously, founders and engineers in biotech and pharma are at the top of the list. If you're building in that space, this is a clear green light to aggressively integrate AI into your R&D workflows. But it's not just for them. Product managers in any domain that involves complex design, simulation, or optimization, from advanced materials to chemical engineering, should be paying attention. This shows what advanced AI is capable of when applied to structured high stakes problems. Even indie hackers could look at this and start exploring niche applications where a high success rate in design could be a competitive advantage. And for infrastructure engineers, this signals a massive future demand for specialized compute tailored to these complex, multimodal scientific workloads. How would I think about it as a builder? This shifts the mental model from AI as an assistant to AI as a co designer or even co inventor. The opportunity is in identifying areas in your product where you currently rely on slow, iterative, human driven design processes and asking, could an AI achieve a similar or even better success rate? Think about generative design for physical products, optimizing complex systems, or creating new formulations. The risk, of course, is that these are still early days. Designed doesn't mean clinically effective or even safe. The details on the specific molecular targets weren't disclosed, which is an important caveat. So, while it's incredibly promising, we have to treat this as an early, though highly validated step. My analogy here is that it's like AI just passed its driving test with flying colors in a simulator, but it hasn't navigated rush hour traffic yet. My no BS take, this isn't hype. A 14-15 success rate in molecular design is a tangible, impressive result that moves AI firmly into the realm of scientific discovery. It's a clear signal that AI is ready for more than just language. It's ready to invent. If you want one practical takeaway from today's episode, here it is. Experiment with prototyping an agentic workflow on local hardware. Given Intel's push for agentic AI from the data center to the edge, it's time to really understand the implications of local inference for your product. Here's how to try it in under 60 minutes. First, pick a simple, well defined workflow in your team that currently involves a few manual steps. A good example might be a basic customer support triage system. Identify issue, assign, search internal knowledge base, draft a templated response. Don't go for anything too complex. Second, choose an open source agent framework that's relatively easy to set up. Something like LangChain or AutoGen can get you started quickly. Look for community examples that you can adapt. Third, run this agentic workflow on your laptop or any local GPU you might have access to. Use a smaller open source model that can actually run efficiently on local hardware, maybe a fine tuned Llama or Mistral variant. The goal isn't perfect performance, but to observe the process. Finally, compare the latency and perceived cost of this local execution against what you would typically experience with a cloud based API call. Pay attention to how quickly you get a response and how much compute your machine is actually using. Why is this specific experiment worth your time right now? Because Intel's announcements show that heterogeneous AI deployment across the stack is coming. Understanding the real world trade offs between edge and cloud for agentic workloads will be crucial for optimizing performance and cost in your future products. This quick experiment gives you a visceral, first hand understanding of what's possible locally and helps you pressure test these deployment models in your own roadmap without needing a massive engineering effort. That's it for today's No BS AI briefing. If this helped, follow the show in your podcast app and share it with one builder you know. And if you've got questions or topics you want covered, connect with me on LinkedIn and send them over. See you in the next briefing.